Welcome to another episode of Teach Gen Tech. And today we have Tim. Yay. Tim, who
Hi,
are you?
Jen. Hi,
What
everybody
are we
else.
what are we talking about today?
Who am I? I'm Tim. We got that far. I run developer relations at a company called Startree. Startree makes a fully managed cloud version of Apache Pinot, which is a real-time analytics database. And what we're talking about today is real-time analytics. And to get to that, a lot of history and a lot of just like what is even analytics.
Yay, thank you. And I remember something, Tim, I don't know if you remember this, when we met via Twitter, and before going into that story, I will say one thing that I started with is the reason I would want to work with Apache Pinot is so I can carry around a bottle of wine with me while going to
Right.
events.
No, that's on brand, and I'm actually contractually obligated to drink only Pinot Noir for the duration of my employment. Not a lot of people know that.
And I would be
But
totally okay with that. That is my favorite wine. So,
right, it's like if you're having some chicken, it's kind of lighter. If you want to go red, you can still do it, but it's still got some body. It's why not? It's just perfect.
yes,
So
100%. And so, talking about that though, do you remember how we met?
I do, I do. We came to follow each other on Twitter, and you were looking for a developer advocate role, and I was looking for developer advocate. So I was like, "Oh, hi."
It was. It was a
That's
fun
that's how I
conversation.
remember. Yeah, and we got on a call and talked, and it the way the way that call went, I was looking for somebody more senior, like that role that I was trying to fill. I needed somebody who had been around a little bit, and it was a senior level developer advocate role, and that wasn't you. But I remember very clearly that you. I mean, that's just where you were in your career. You weren't that.
Mhm.
But I thought this person absolutely has what it takes to succeed as a developer advocate. This is a tricky way to say it, but like you have the personality, you have the communication skills, you have the curiosity. That this was like a year ago, wherever it was. I'm like, yes, this
Yeah.
person. And if you look at what you're doing here, just a meta, talking about Teach Gen Tech, um, this is what when I'm able to hire somebody who hasn't had the title developer advocate, um, and like maybe a senior engineer or something who wants to make the change, I'm looking for people for whom developer advocacy is what comes out of them when they're not paying attention, right? It's just like you prick them and they bleed teaching people things and wanting to explain things. And I don't know, seems like this show we're on right now is an example of that, right? This is what you do. It's not enough for you to learn tech topics, but you're going to do it in public in a way that other people can learn too. And that's like
It's
um,
interesting. It's interesting.
the heart of the teacher and the kind of person who wants to share is the core skill set. The tech skills you can learn, and they change all the time anyway. You know,
They do.
so you're
And
always learning new tech skills.
thank you for answering that. And I promise I didn't set it up just so that way I could get, some fluff in my feathers. It's because I really want people to hear two parts of just because you've never been in a role doesn't mean you can't get there. And also, you can learn so much by interviewing and also create a
Mm-hmm.
network. It's kind of
Mm-hmm.
weird, but like people I interviewed with, like you, I'm like, hey, can I follow up with you sometime? And yeah, it's a bummer for not getting a job, but it really helped expand my network. And that's something that I
Right.
really want to call out to others to not give up hope because it can be hard to break into any industry. I think it's difficult to break into DevRel, especially when if you have an engineering background or not, like being able to merge the two and showcase that. It's like a different
Mm-hmm.
learned skill.
Yeah.
Oh, okay.
Yeah.
We do have quite a few in the audience, and I promise y'all I'm not ignoring you. In the background, I used to do these
Bakari.
streams
Oh,
with
hey, man.
yeah, I used to do these streams with my iPad,
Hi.
and at the moment it's not working. So I'm gonna stop paying attention to that and say,
Okay.
what up, learner? And Francesco and Bakari. Yay. And yeah,
Hey,
Bakari.
Francesco, I owe you an email. I know. I'm sorry. It's been a rough, there's a lot going on in June for me. So
It's all my fault, Francesco. Sorry. No, I'm just kidding. Yes, tell us about what's going on because you do have a lot going on this month.
I do. I do. I have lived in Denver since 1995. Prior to that, it was 77 to 90. So, like, literally 80% of my life. Um, and in Italy, you're pretty relaxed with timing. That is the reputation. So, and that is why Italy is such a glorious place. Anyway, yeah, I've lived in Denver 80% of my life. And on last week at this time, I was boxing up my apartment and loading up a U-Haul. And we drove starting Wednesday night through Friday night. I arrived in Mountain View, California on Friday. I am now a California resident, doing all the residency establishing things. And in 11 days from the time of this stream, it is June 13th today, on June 24th, I am marrying an absolutely fantastic and amazing woman, uh, currently named Rachel Stark. In 11 days, she'll be Rachel Berglund, and I'm super excited about that. So,
Yay.
yeah.
And y'all, um, apparently I didn't pay attention to the memo that for the last 2.5 years, Tim and I lived in the same area.
Yeah.
But
I'm gonna be
hey,
back every couple months. I still got family there. I have a grandson there, daughter, and I'll be back. So yeah,
I'm
I'm still
moving
gonna
to
come.
Phoenix at the end of the month.
Well, there you
So
go.
in
All right, I
in
am definitely
roughly
not.
2 weeks, I'm going to
Mm.
Phoenix. But hey, we're gonna have
But
Ivan's
that's
gonna have a meetup in San Francisco. How far is Mountain View from San Francisco? Aren't they like next to each other or
yeah,
no?
it's Bay Area. It's a half an hour in low traffic and an hour in crappy traffic.
Okay, because
And
we're gonna.
I don't know if Ivan and Star Tree want to do a joint meetup because you guys
It's the
host ClickHouse. But we love you.
it's the open source data infrastructure. So it's when we get to be
Okay, well,
friends. It's when we get to
okay,
be
that's where.
friends.
Yes, yes,
Yeah,
love it.
yeah,
And we're friends anyway.
that's true. That's true. And hello, Anthony. Yeah. So let's get into it. Sorry, y'all, you won't be able to see my notes during the stream because my computer just doesn't want to do it. But I will still take notes and let's everyone is Tim's friend. Is everybody Tim's friend? Are you just
Well, I
friends
mean,
with absolutely everyone?
I aspire to be friends with everybody I meet. It doesn't always work out, but those are a small fraction of cases. So yes.
I like it. I like it. I feel like I always it's kind of fun because for some reason I don't see a lot of your posts except when you reply to somebody's selfie Sunday.
Okay, that is a friend who is not in tech at all. I can say her name. Her name's Courtney Sexton. She's not in tech at all. She's a friend of Rachel's and mine. Her her husband is a mid-career boot camp guy. So he
Ah,
just graduated
okay.
boot camp, is looking for his Dave Sexton is his name, looking for his first boot camp job or first junior developer job out of boot camp. Super sharp guy. Like he has taken to this stuff. So,
Nice.
ping me,
Yay.
y'all. Bakari, you're okay. You're moving. Oh, dude, I was gonna say I need to have you over for dinner, but I can't do that in the next week and a half.
Yeah,
Um,
Bakari, you're moving to Atlanta. Atlanta. I think it's
mm,
Atlanta.
I feel like
Yes.
you're winning.
Okay.
I'm glad to be
Okay.
here, but I still feel like you're winning. Um,
Yes. Uh
yeah,
oh yeah, that's true,
Bakari's gonna sell his
Francesco.
house here and buy a palace in Atlanta for cash. That's how it goes.
Even
Anyway,
even the cost of living from Denver to Phoenix is like we're getting a much bigger house in Phoenix.
good, good.
And
Yeah,
I'm
yeah.
just like,
It's gotten rough recently. I
yeah.
And I'm still paying about 2x here relative to what I was paying in Denver for rent. But yeah,
Yeah.
hey.
Yeah. But, you got to do what you got to do. And all right, so let's get started. What is real time analytics? Because and for context, because I know a lot of people are joining because it's Tim, and welcome. And I'm totally going to do a self plug of make sure you follow, subscribe if you want. You know, that would help too, but follow because I need followers.
Yeah.
Um, I am a developer advocate at Ivan, which is a database management company that we oh wow, I don't even know how many Francesco, you're here, so how many databases do we service or help out with? Because I know Postgres, MySQL, Kafka,
Like 600 of them at
ClickHouse.
Ivan. By the way, hi, Robert. I just saw your shout out. Sorry, in the chat. Yeah,
What
there's like
up,
600 of them that you guys
Robert?
host, right?
Yeah, like there's a lot. And a lot of what I do is I work on getting people started with these different products. Like that's the content I'm working on with Ivan, as well as meetups. And then I'm still learning about databases with Teach Gen Tech because if you check out YouTube, you'll see streams of what is data and intro to databases and like the difference between SQL and NoSQL and we're getting there. We've done a stream on Kafka and I still don't understand it, but that's okay. I will get there. And yeah, so that is the background of why I ask about what is real time analytics.
There you go. And with respect to all that stuff, like, I mean, this is Teach Gen Tech. The conversation goes where Jen wants it to go. And so, whatever, if Kafka comes back up this week, that's great. We're going to do this again next week and talk more specifically about Apache Pinot. And so, that could be might talk about Kafka more there. We'll see.
Cool.
But can I just back up before we talk about real time analytics?
Sure.
It makes no sense to talk about real time analytics before we talk about analytics. And
Good
I
call.
have been, and maybe this is like a thing that a middle-aged person does. I've just been thinking about the things in their historical context a lot recently. Um, and I think that helps clarify just what analytics means, because Jen, you're interested in databases, but if we would just rewind back to the beginning of commercial digital computing, that's the mid to late 40s. The first computers that we would call mainframes are being developed and sold. We think of them as IBM. There are a few other companies who are in that act. And these are single threaded batch machines that compute analytics. Okay. That's the purpose. Commercial computing begins with analytics. The modern story of analytics begins with at the same time as commercial computing. And so you had a bunch of data, and there had been in the decades. By the way, I live in Mountain View right now, and just up Shoreline Boulevard is the Computer History Museum, and you can actually see some of these things that I'm talking about. And that place, I don't want to be weird, I literally weep sometimes in some of those exhibits. It's just really affecting to me. It's amazing the stuff that's there. But you had in the decades before that mechanical tabulating machines where there's data on punched cards, and it's kind of doing basically adding of things. But then the first mainframes are taking data in batches on punched cards and running software. You could write arbitrary programs on these things, and they're doing batch analytics. Okay. And it's so difficult, and those machines are so expensive. And the model, IBM leased them. You didn't buy these things, you leased them for, if you make the inflation calculation, it's hundreds of thousands of dollars a month. And
So expensive.
right, without even adjusting for like GDP and all that stuff. It was a smaller world back then, but um, they were so expensive that only the largest scale businesses could justify the expense. Okay, the auto shop down the street is not going to have a computer. We know that, right? And so large scale businesses and governments, we're talking banks, airlines, utilities, things that operate at that nation scale, governments by definition, they're buying computers and they're doing batch analytics. And so it's such an expensive thing to do that only these very high status leaders in these very large, valuable organizations are able to do analytics. And there's a big separation in time between the events happening out there in the world and someone encoding the events in punch cards and then writing a program ingesting blah, right? So
Quick questions
it,
from the
yeah,
audience, real quick. Was that building used to be Silicon Graphics? About the
SGI, yeah, boy.
and then
Yes.
also, is that the same place Adobe and Netscape co-founders worked at together?
I don't know. Adobe's founding might have been contemporaneous with like early days of SGI. Netscape, uh, possibly. I just don't know the answer to that one. But Bakari is, I mean, he's lived here longer than I have, so he'd know. But yeah, that's the former SGI headquarters. And it's
I
anyway, if you're in the area, if you're coming to my wedding, it's on the list of things to do. On the site on the knot. So yeah. Um, anyway, that's the start, right? It's very expensive. It's very difficult. You have to be a high status leader in a very valuable, large organization to be able to do analytics. And then, we chip away at that. That's the late 40s. By the early to mid 60s, you've got the System 360. And this is a mainframe that is the first kind of thing that we would recognize as a computer, kind of like we think of them, because it has an operating system that runs on it and you write software that runs on that operating system, and that operating system is going to get ported to other models in the same product line. Like you have OS 10 and it runs on various Macs and they're all the same, and you write the same program and they're all there. That's the way we think of the world. So you get there, right? And people are still doing analytics, but now all of a sudden computers are fast enough that it's not just a bunch of punch cards in and some punch cards out with smaller numbers on them, but now you connect terminals to them. And so computing is powerful enough to be able to handle transactions. Okay, so when we talk about analytics, there are these two kinds of databases in the world. There's transactional databases and there's analytics databases, OLTP databases and OLAP databases, those two terms, OLTP and OLAP. And OLTP, transaction processing, wasn't even a thing until mainframes got going for a little bit and they were fast enough that you could hook up terminals and do this stuff. And so now by this point in the 60s, it's commonplace to have terminals connected to computers and multiple people doing multiple things. And so now you have, some kind of knowledge worker doing their job, accessing data on a computer. And that's
Okay.
that's not analytics happening there. That's transaction processing. So usually what that program did, and that's the old green screen kind of life is what they had then. And basically what they're doing is CRUD over entities, right? There are things in the world and they're using the software to create them, read them, update them, delete them. And that's most of the software that's been written in the 2 or 3 human generations since that started. You've got these transactional databases with people just accessing entities and looking at them on their screen and making them and changing them. And so there's
Really quick.
interactions out in the world. Okay, go ahead. I'm talking a lot. Interrupt me.
No, you're good. You're good. I'm just like, I know I'm gonna forget this question. Um, okay, so you got transactional, which is OLP, and then you have
OLTP.
LLTP.
OLTP.
Cool. That makes
Online
sense.
transaction processing. OLTP.
Which I'm just gonna write these definitions down so I don't forget. Online
That's a very good idea.
transaction transactional. That I hopefully can read my own handwriting. Uh, program. Sorry, what was P?
Online transaction processing.
Processing. Thank you. Um, and then the other one was analytics.
Online analytical processing. OLAP. Yeah. OLTP
Okay.
and OLAP.
It was the thing that I'm like, I'm pretty sure um that was it, but okay, cool. And then I like how you gave the example of crud. You explained it and I'm like, I think this is the first time somebody has said it out loud that it actually clicked of what crud meant because I wrote it down really quick. I'm like, I don't think I ever clicked that it
Create,
was
read,
create,
update,
read.
delete.
Yeah. I was
Yeah,
like,
yeah,
what? What? Okay. Thank you for
yeah.
getting those there. And
And
yes, please continue.
so, awesome. So and by the way, I love talking about stuff at the super fundamental levels. This is I think this is important because we don't, even people who have been around the block for a long time and like we think we know all this, you don't always think, wait, what does that really mean? Like, what's a transaction? Because if you know transactions, you're gonna be like, well, you've got commit and rollback, and you've got two-phase commit, and blah blah blah. Look, nobody cares, right? What's a transaction? Well, what does a business do? A business exchanges things with people.
Hmm.
You have, like, you make something, it's a valuable thing, and you give that to your customer. And what does your customer do? Well, your customer is so happy that you gave them that thing that they give you money.
Hmm.
And people do it voluntarily, and it's wonderful. Um, and so there's this exchange of value that's happening. Um, Fundamentally, that's like what a business does, and that's modeled in account. You see that in like double entry accounting. That idea, that's what we're talking about. So fundamentally, and there are other ways to use OLTP databases, but when you're talking about the activity of a business, those exchanges are happening, and you are recording them in the database. That thing happens out there, and you keep a record of it. Or, hi Graham,
Hey,
uh,
Graham.
you are keeping a record of a thing. Like, I'm a user of a system, and I'm doing all these address changes right now. So all of the update operations, I want to go read my account, show me my address right now. Okay, edit, click, new address, update. So you're either recording transactions or you're keeping track of the state of things out in the world. Fundamentally, that's what transactional databases do. And the point I'm slowly
You're
making
good.
here is
You're
that
good.
computers had to get fast enough to where that was even a meaningful thing to do. And then they did, and there are all these terminals. And if you look, like, I travel a lot, if you ever look at the screen of the airline person, at the ticket counter, you ever wonder, why are they typing so much? They're just typing all of this stuff so fast. Uh, it's really strange, but they're using a terminal emulator on a modern computer that's this interface software, closely related to the stuff that was developed literally before I was born, and I'm turning 51 in 2 days.
Happy
So
birthday and happy
thank you.
congratulations and yay move. I'm gonna keep
It's a
finding new
big 2
ones.
weeks. That's right. Um,
So is that a big reason why, and I'm just trying to think of a real life example of what happened with like Southwest during COVID, or like last year, I think it was, where all of their flights and things crashed because it from what I remember, it was more about their software couldn't keep up with it, and so
yeah,
things got crisscrossed, which
I don't
in turn
know.
makes
I
me
don't know
think
any
databases.
details. Yeah, I don't know any details of why that went down. In general, I wouldn't blame the platform. I mean, airlines run on mainframes, and a lot of travel, deep under the covers, there's still mainframes doing that stuff, and that stuff can scale and be reliable and run, and you can screw it up. So I think that had to do with, and last Christmas there was the big crazy thing because there was
That's
like lots
it,
of
yeah,
travel and then some weather, and that's just kind of airline instability because there's not a lot of slack in that system, and when one bad thing
right,
happens, it yeah. But mainframes started as analytics machines. Now they're doing transaction processing, and analytics, or what we then called reporting, was just a feature of the software because all the data is right there. Okay, it's
right.
one database to rule them all, one database to find them, one database to bring them all, and in the darkness bind them. And then you've got, software, an application running around that database. So the transactions, the analytics, they're all the same. It's all fine, right? And so we're
Mhm.
bopping along through the 70s. And then in the 80s, some things happen, which is basically PCs. Okay, so now we're good enough at making computers that you can make a sufficiently powerful computer that it can do a lot of that knowledge work stuff locally. You can actually have programs running on that thing. Maybe it's still a crappy green screen and life sucks in 1982, but it's fast enough that it can actually run programs that you can use. And people start connecting those computers on networks. There's this big revolution happening in the 80s
Mhm.
called people talking about LANs, local area networks, and open systems. And now we've got little database servers. Like Oracle starts as a company in the 1980s, and you take one of those PCs, maybe a bigger, beefier one, and you put Oracle on it. Maybe it's not a PC, it's a Unix workstation, whatever. But now there's this server on your network that holds your data, and you've got all these PCs networked to it, each running their programs, talking to that data. And that's an interesting new approach because it's cheaper to build out and it's easier to change. And so it revolutionizes the way business computing happens. Now everybody's got a PC in front of them gradually, and there are these database servers on the network, new terms, and it's not just one database server. So in my department, I get some budget for my own database server and my own application. And in another part of the business, they want to do their own thing. They're tired of being controlled by the mainframe priesthood. And so they get their own database server and their own application developers, and they're building their own stuff. And so now all of a sudden, instead of this centralized tower controlled by a priesthood, you've got local control and kind of this flowering of innovation, but oh crap, your data is everywhere. So what used to be all of my transactions were done in one database and I could just do reports in that one place, now the data is everywhere. And so how do I know what's going on in the business? So there's this revolution in application architecture that happens in the 80s. Instead of everything's on the mainframe, we go to a paradigm called client server, where the client is the PC. There's software running on the PC. The server is the database server somewhere on the network. That's a completely different way to write software. And that breaks the way that we've done analytics.
Um, I have questions about this. I also want to catch up
Yes.
on the chat of Graham said Southwest was something to do with a storm, caused loads of delay. The software couldn't actually handle all the updates and to the schedule and crashed. Okay, yay!
True story.
Hello again,
Both of my
learner.
daughters were visiting Denver from out of town. No,
Mm,
sorry. One of them was trying to take a trip to visit her in-laws on the East Coast. The flight just got canceled. And they're like, no, you can't have a flight for another week. Like, didn't happen. The other
mm.
daughter was trying to fly back to San Diego. They ended up driving. It was crazy. Anyway, go on. Sorry.
Yeah, no, you're good. And Parasocial can get a database with $5 a month with PHP hosting.
Yeah, they're pretty
That
cheap now.
Yeah, yeah, and I feel like I'm getting there. Um, so I liked the way I wish my iPad was working to stream. I'll have to figure this out later. The visual of that Oracle was like the local network database and then the LAN to everything else because that also helps why Oracle started. And then the way you said it was a client server, meaning that they ran the software on their own computer, but was still asking the database for from the local network.
Yes, yes.
Okay.
That was the new paradigm. Instead of all of it centered around the mainframe and you've got a terminal that connects to the main. I mean, we complain about monoliths now. The original monolith was the thing that came before client server. And I was a nerdy teenager in the 80s reading Byte magazine. Anybody of a certain age in the audience will just feel waves of warm nostalgia right now. And at that time, this was the thing that like the wild-eyed revolutionaries were carrying the banner and calling people to the barricades to tear down the tyranny of the mainframe and replace it with PCs and LANs and client server. It was really a big thing. It was a revolution in application architecture and in the economics of computing, which is itself is cool. And since we're telling the story of analytics here, it broke the way analytics worked.
Real
With that
quick,
transition, the tools that we had didn't work anymore.
I'm going with context here, and again, this is probably my favorite thing about the show is I will ask what I think are the most simplest questions, and I'm like, I'm actually going to ask them now instead of just hiding and being like, I know it. No, I don't.
Right.
Mainframe, is that just the big computers before they went to home computers, or what? How would
Yeah,
you describe
basically. Yeah,
mainframe?
yeah, yeah. Yeah, it was, I mean, at first they were the computers that we were able to make, and they were big and heavy and
Okay,
required special power and everything. And that the first digital computers that human beings figured out how to make were large and expensive and physically heavy and
right.
needed three-phase power and cooling and all that stuff, right? Because that was the best we could do. And that paradigm of the one giant machine is just the paradigm that we carried forward for about 30 years and just got better and better at it, right? Like we went from vacuum tubes to transistors, transistors to integrated circuits. We became more modular, and IBM with System 360 and the work of Fred Brooks, the late Fred Brooks, he finally passed away last year. A common operating system that would persist over different versions of the hardware, all that stuff. But the basic idea of a computer is a giant thing that goes in
Mhm.
a special room and you need to cool it and order special power connections, that was the mainframe, and that was the paradigm that just got carried forward for 30 or so years. Yeah.
And, Graham said, "Haha, yes, you can, but through input, not scale of tens of thousands of users. This is why we have such complex infrastructure."
Yeah, that was, I think, responding to Parasocial about the $5 a month, like that $5 a month
Yes.
database with shared hosting, that works, solves a lot of problems, but some problems it doesn't solve, and this is
Yeah.
why you have other systems. Yeah.
And, which is really ironic as now we are going back towards thin clients.
Yeah, yeah.
Thin
And
clients.
I'll get later on in the story to what I think is happening with application architecture now. I mean,
Okay, and then
the web disturbed what we meant by client, but we'll get there.
and,
um,
learner said UNIVAC time, and I feel like you did go through that. Was UNIVAC what
yeah, yeah.
the different okay. And
Wasn't
then
the first
learner
mainframe, but it was an early one. Yeah,
okay. And then, learners just mentioning they didn't know much, about computers until middle school, but that's, really way after all these machines. I will
yeah,
say I was in the 90s, I was fortunate enough that my dad bought all the latest and greatest things and tried to tinker with them and break them apart, so I got to see a lot of it, but I didn't ask a lot of questions back then, and
sure.
but it's starting to piece together as I have people on the show, I'm like, "Oh, that's what
Yeah,
that
yeah,
was," or
yeah.
why people would go, play StarCraft at a LAN, um,
Party.
yeah, LAN party cafes, computer
Hmm.
cafes, they used to be a
Hmm.
thing. But, okay, so we got to the point where we have the client server and it still connects to the database on
Great.
the network.
Yeah, and client server is uh, Graham. I I Prince of Persia. This is good. This is good. Maybe we'll go there. Uh, I don't want to play the I'm old enough game just yet, but um, client server was compelling economically and technologically and was winning. Um, but the problem now is that all of your data that describes, remember all those transactions happening in the world, and they used to
Mhm,
be reflected in that one database, and reporting was just a feature of that program. Now there's dozens of databases that all those transactions for different business units and departments are in, with all those different business leaders wanting control over their own application and their own data and having it now because like computers are cheap enough and they can put PCs on desks. And so how do you have one view of what's going on? Well, this is where the data warehouse enters. This is a late 80s, early 90s technology.
Okay.
Um, and the idea was, okay, fine, you've got all these departmental databases with all these different transactional schemas all over the place. We're going to write a program that at night, because again, this is kind of a pre-globalized world, and so you do business during the day, and then computers sleep at night. At night, we're going to go read all of the transactions that happened in the previous day from all of those databases. They're all in different formats. Everybody's got a different view of the customer, different schema. And we're going to take all that, mush it together, try and unify all the different views of things and transform the way the data is structured, and then load it all into a completely separate database. That database is called the data warehouse. So you got all of these departmental databases. We're going to suck all the changes from yesterday out of all of them, transform them into a new format, and dump them into the data warehouse database. Now, that data warehouse database was still like Oracle or whatever, right? It was another relational database. We're not talking about database technologies in this, but by this time, everything is SQL, everything is relational, pretty much. That's really starting to win by say 1990. But that data warehouse is rising right about then, right around the time of the first Gulf War, if that helps put it in any kind of perspective for anybody. And that now becomes this generation-long paradigm of the way analytics is done. And we had to develop that because of the change in application architecture. People are doing client server now. There's all these databases, and we need to do this thing to get all that database into one place. So now I can write reports on that.
Mm-hmm.
And it's still a batch process, right? It's running at night. I can see what happened yesterday this morning, I see what happened yesterday. And at that time, this is all oriented around a printed report. So somebody's designing a report in report designing software. It gets printed out on a laser printer. And it's still pretty expensive at this point to do all this. So you're still a pretty high status business leader. Now, lots of different kinds of companies can have computers now. It's not just airlines and banks and utilities and governments. Any even medium-sized business is doing this, but you got to spend a lot of money. And so you're not doing this for everybody. You're doing this for senior leaders in the organization. They're getting printed reports about what happened yesterday. And that sounds slow by modern standards, but at the time, again, these are wild-eyed revolutionaries blazing a trail saying, I can get you all that data back that for the last 10 years has been locked up in these departmental databases that we've all been getting so excited about. Now I can show you what happened in your business yesterday. And this really sets the tone for the modern era of analytics. This is 30 plus years ago, but we've spent those 30 years working through that paradigm. So I'll pause there for a second and take us to the modern world. I don't know if you got questions.
I don't know if I have as much questions as much as this is really helping understand a lot more about databases, but also about how we went from just words, Jen. So I've had different guests on the show to talk about the different types of databases, or Ben Gamble, who's also from Ivan. He came on the show to talk about just data in general, like from the
Yeah.
computers to go at all the. So that really helped. And a lot of what you're saying is just piecing these things together. But then
Yeah.
also, and I'm curious to see how analytics were built up and how it's become much more real-time analytics, which we're going to talk about, because when I worked at GoDaddy, it, the analytics were still delayed. And when I think about analytics, I think
Mm-hmm.
about probably more on the client side of like Tableau. Is that what it's called? Tableau? I think so.
Tableau. Yeah.
Yeah. So I'm curious to hear more about um how that evolves, because why those were still delayed. Are they still delayed? I haven't worked at GoDaddy for 5 years now, so a lot of things could have changed in the last 5 years. I'm pretty sure it did, but that's where my head's at right now. And we do have a question from Anthony of
Yeah,
why
yeah, yeah.
did Postgres win relational?
I don't have a good answer there. I mean, learner, that's true, but MySQL was uh, was open source and it had years of development. And I mean, I think MySQL is how the MySQL folks say it. MySQL might disagree, but I mean, I would agree that Postgres is kind of the de facto choice. So yeah, parasocial, define win. I mean, fair enough. I think it's fair to say that um, Postgres is the de facto go-to open source relational database. It's not the only good one, but Francisco, if you got to, I love your thoughts in chat. It seems like you need to, for professional reasons, would want to be thinking about this yourself. So I'm not sure. I'll just say I'm not sure. I want
I
to.
feel like Anthony asked that because he knows. So for those who are curious, Anthony is who I like to call my internet big brother. He is the one that the like third person I talked to and was like, dude, you should live stream, and was my second guest on Teach Gen Tech. So that was lovely.
Nice.
And
Oh,
he likes coming on the streams and asking really difficult questions.
nice.
Just which I always find pretty funny. And Francesco is my colleague, but also my own mentor and helping me understand a lot of this, because this is a lot of shit to learn. And then also comparing it to where I work, it's very helpful to be able to balance the two. Um, and yes, there's so much more going in. I'm glad Francesco loves Postgres, because that is the first one I am tackling, but also it could also be just because their logo is an elephant and I love elephants. I feel like that's not a good enough reason, but
It's
I'm going to
difficult.
stick with
It's
it.
difficult not to love elephants, Jen. I think that's fair. So let's we have data warehouses, right?
Yeah.
And we are just on the cliff right before we jump off into the web now. So the
Mhm.
early to mid 90s, the web starts to happen and changes everybody's life. And we've completely reimagining the ways that we buy dog food and kitchen utensils and deodorant, and e-commerce is a thing, and the dot-com boom. Um, a lot is happening in terms of the way computers are connected, in terms of the way we access information, so blah, blah, blah. Not much is happening in terms of application architecture, okay? The web is hugely transformational, but we are still essentially building client-server systems. The stuff that we learned how to do in the 80s, when the web hits in the 90s, we use all those same tools. And now we build client-server systems, and suddenly because client server was small. Remember, it was the whole idea was I can build something just for my department and have control of it and not the whole company wide mainframe. Now we're using that paradigm to build websites, some of which become huge. And that's an interesting story. And it's kind of not our story right now. But there's some strain on the client server paradigm starting to show by 2000, 2005. We're seeing that kind of not always handle everything so well. And the reason why you mentioned GoDaddy, Jen, I meant to get to that, but the analytics were delayed is because everything is a batch process at this point still. You have what happened yesterday and it's nighttime, and then you load it into the system that lets you see it. So there's transactions happening here. Next day, analytics can happen here. And it's very much a batch world. It was a batch world in 1947, and it's a batch world in 2007. There's not a
Okay.
lot of real time. I mean, there's every time I say real time analytics is a new idea. Like if I go tweet that, 6 people will say, "Well, I was doing real time analytics," and yes, of course, like people built special things, but it was not a mainstream practice. Analytics was a batch operation, and the strain on the data warehouse. Remember, the data warehouse is you collect all this data, you put it into the system. Well, now what we're seeing is not so much that there are lots and lots of systems, but we're back to there's one big giant website sometimes, and we need to do analytics over all that data. And suddenly the volume, it's more common to collect a very large volume of data. You don't have to just be a utility or an airline or a bank or a government. There are these internet startups, there's the .com boom and crash, but into the 2000s, still there are big web companies, and they're seeing that this loading all your data into Oracle to run reports on Oracle just doesn't work. And so Hadoop is born.
A what a bird?
Hadoop is a product, a system, an open source system called Hadoop.
Okay.
Yeah.
Francisco replied to, and then I'm going to ask you more about Hadoop. I love Postgres and currently assisting to fast growth in usage. He believes that it's very easy to use. It has a very deep set of extension covering a wide set of functionalities and a big, healthy community behind it.
Okay.
I like it.
All right. All right.
And I'm
And
100% not going into what the rest of you are saying because I don't understand it yet. So y'all have fun. And
I
oh
would
geez.
sooner. I'm going to let the JavaScript. I will not enter into a JavaScript debate in a live stream. Every comments are yours.
They can
Please,
have
please
fun.
do. I'm going to
They
leave
can
that,
have
and
fun.
it's not out of disrespect. It's out of not being qualified. So, in about 2010, we have Hadoop, Hadoop. Its logo, Jenn, also an elephant.
Really?
Yeah. And it's
Is
not a going concern anymore. Okay. It flowered for a couple years, and we are now dealing with kind of third generation Hadoop's grandchildren. But basically what
ah,
it did is it said, we can't have just one computer being a database anymore. We have to spread our data out over a cluster, arbitrarily scalable cluster of computers, and then we'll spread our computation all over all those machines.
okay.
And um, and Parasocial, I love how you are what's the word? You are dropping the hot takes like you don't care, and I love it. And
Parasocial
there's
will
just the
post like the spiciest stuff.
this is the third time. So first it was databases, then JavaScript, and now you're like NoSQL's over. I mean, I happen to agree that NoSQL's over, but I like the spice. I like it a lot. Please continue. Yeah,
That's why I
MapReduce
leave
was
it
the
to them.
future. MapReduce was the future for like 5 minutes, and it was also a terrible way to live. And and I don't want to get into MapReduce. It's to some degree not the point, but nobody used that. Layers developed on top of that. Which Parasocial, what was the common one? It was Hive, which is, I'm sorry, what's the language that is again? Oh yeah, SQL. So yeah, NoSQL didn't really wasn't really a thing. It was an important movement in database technology, but the attempt to get away from the relational model and from SQL failed. Anyway, slight distraction. I want to stay focused on analytics because we only have a little bit of time left to get to real time. So this new revolution, these are still batch technologies, just like they have been since commercial computing started in 1947. All right, ish. So Hadoop is now, instead of one big computer that's a database, we have 200 small computers that are acting as a giant database. But you still take your transactions from a little while ago and then load them in, and then you write reports. We're doing the same thing. We're just doing it bigger.
Hmm.
Yeah, so that happens. Hadoop itself doesn't survive very long as the technology, but that paradigm, I mean, it's an incredibly fruitful idea. It just gets improved upon in Spark, and now you've got the other things in that whole ecosystem. that are all this idea of the data is going to be out there, and we'll do a bunch of computation on the data out there in S3 or out there on these computers or wherever it is. So around the same time as Hadoop, and for some reason this just feels like a cheesy thing to say, but
Do it.
mobile devices become a thing,
I
right?
think you just wanted to show the cute picture of you two because you're getting married in 11 days.
It is a cute picture. Okay. But around that same time, smartphones, not mobile devices, but smartphones become a thing. And so we're now in a world where we're constantly always connected. You don't go home to get online. You're there, and we get accustomed to the fact that a notification makes the thing in our pocket wiggle when something happens out in the world. Okay, so more and more of our social lives and our commercial lives are mediated through computers that are constantly connected. And we develop the expectation that stuff happens instantly.
And
So
this also goes into protocols and like when we had POP3 and IMAP on how quickly things were grabbing the information as well.
Yeah, I mean, POP3 would be an example of a batch and IMAP. I mean, those are batch technologies, right? Your email client every so many minutes has to go check and get stuff and bring it back. So that's like a batch way of doing it.
Okay.
Yeah. And so, yeah, parasocial apps on phones, by implication, notifications in apps on phones. And so we're becoming accustomed to the fact that stuff happens right away. You don't know about something the next day. You know about it right now. Yeah, Graham, we're just about there. I know it's taken a long time, but I like telling this story. So
It's
thank you for
helpful.
sticking with us.
It's helpful.
Good.
So y'all, thanks for sticking with because this is going to help me learn and be able to tell other people about it.
This is Teach Jenn Tech. Jen's taking notes. So, all right.
I am.
And remember, I said that client server paradigm, when the web happened, that's how we built things. So we just kept using that. Well, that's under more and more and more stress as you get into 2010, 2015, 2005, 2010. People start complaining in about 2010 about this one giant application. You've got this database and this big, giant, complex application that does everything. It's one code base, you deploy it all together, and it's super hard to change and all that. And we start using a negative word for that application architecture. We start calling it the monolith. And a monolith is bad, right? It's the mustachio twirling villain all of a sudden. Around the same time that Hadoop is happening, this paradigm falls out of favor. It's just another way of saying kind of big client server application, but it becomes bad. And so people start breaking their systems apart into small programs that talk to each other, which we call microservices. So,
Wait.
You've heard the term.
Oh, this is weird. Like when something finally like starts to click. Oh,
Yeah.
it kind of made
Yeah.
my head hurt.
And well, I hope in a good way, because the reason was it was too hard to scale and deploy and change and think about the giant monolith. So if you can break that into lots of small programs that are small enough to fit in your head, then each developer can kind of understand the whole thing. And parasocial, I would not co-sign that. I would say there are lots and lots of stateful microservices, and yes, less state always means your head hurts less. State always has a cost, but the problem is that, and this was a problem when people started making the first microservices systems, that state was really hard to deal with. And so I'm going to go a little teeny bit into Kafka, just a teeny little bit. Around this time at LinkedIn, it's kind of 2010, 2012. They're making this migration to event-driven architecture, breaking applications into little pieces, wanting data pipelines, and they actually build a system that ends up being called Kafka because one of the guys who wrote it was a literature
I
minor in
never knew
college, and
that.
just yeah, Jay Krebs is a literature minor. He
I never knew it
wrote
was LinkedIn that like built it too.
absolutely LinkedIn. Same thing with Pinot. So like this is my second company in a row that's LinkedIn infrastructure. But um, yeah, and he wrote a system before that called Samza, which was the surname of I think the guy in Metamorphosis, the guy who turned into the cockroach, Gregor Samsa. I don't know. I don't know my Kafka, the writer, very well. But anyway, point being, they build Kafka as a way of getting services and data pipelines to exchange messages with each other in a more scalable way. Right. So now you've got big program broken apart into lots of little programs that are shipping events back and forth through logs.
Mm-hmm.
And what we have there is another massive change in application architecture. I emphasized this back in the 80s at the client server stuff. Okay. We had the mainframe and now all of a sudden PCs and a departmental database on the LAN. And I said this was a totally different way of writing software. The internet happened. That didn't
Mm-hmm.
even change it. Well, now finally, the internet happened to us hard enough that we start to transition to this event driven architecture or these little programs exchanging events with one another. You could just call that microservices if you want. Um, and difference, briefly, parasocial difference between queues and logs like Kafka is the log is persistent. Yeah, Robert, I skipped over SOA because I don't want to use bad words. No, I did. That was an attempt to get there. And if I wanted this to be 2.5 hours long, but you're right, I
I
did.
mean,
I'm gonna
like,
keep
if you
skipping over
want
it.
to go into it, I'm down. But I think he's just setting it up that one of you need to come on the show and talk about it now and give
There
a
you
history
go,
lesson.
Robert. You come talk about
And
SOA.
thank you, Owen, for the
Hmm.
subscription. Oh, it was
Woo-hoo.
from Roy. You're gifting them. Thanks. I appreciate it.
Yeah.
Yay.
Um, SOA was an early and ultimately failed attempt to do what happened later with Kafka and microservices. And what happened with Kafka and microservices is now, instead of one giant program centered around a single database, we can have lots of little programs that each do a small part of the work and talk to each other through event logs. Now, that's a hugely pregnant statement, and I'm going to mostly just leave it. Like, that's a whole other episode that honestly, Jen, I could recommend some people who do a great job
I was going
in
to
the
say, I
details.
feel like I need at some
Yeah,
point someone to like be like, okay, you've had people on about each of these, so now what's the difference
yeah,
between event driven and real time analytics, even though they're like different, but why are they different and
yeah,
what
yeah,
are their
yeah.
use cases, that kind of thing.
I'm going to call it right now. Chris Jenkins. You should get Chris Jenkins on
Chris
event-driven
was supposed
architecture.
to be on the show at one point.
Okay, well,
Please tell
there's
Chris
a
to come
lot of
on.
things Chris could talk about. Like you want,
Please
uh,
remind Chris. Everybody go remind Chris that he needs to be on the show.
and now Chris, I'm going to insult you. Are you Haskell or Erlang? I get my uh, you know, small population of user purely functional languages confused. That was shade, everybody. Uh, Chris is a good programming language guy. He'd be a great guy for event-driven architecture. So anyway, um, um, where
We
was
were
I?
on
Okay, so
event.
now
Yeah.
microservices, and this is a another paradigm change, actual large disruption in the way we build applications. And now I'm talking to people, many of whom have gone through this. Okay. So if you were like building monoliths for a few years and loving life, and now all of a sudden you're refactoring to microservices and you're like, why does life suck? I don't know how to do this. That's because it's just a different way of doing things. And we're kind of experiencing that together now. And we're making our way through that paradigm shift, like being a mainframe programmer in 1975 and then in 1985 having to be a client server programmer and making that change after years of experience on the job. So it's happening again, and it's a good thing, and it's compelling, and it's going to continue, and you don't all have to do it, but like it's happening, and it's a good thing to learn and surf the wave rather than letting it crash over you. But what happened last time we had a major change in application architecture? That upset the analytics apple cart. The way we were doing analytics didn't work anymore, which gets us finally to real-time analytics. So what's going on here? These two things happened. One, we transitioned to this event-driven microservices application architecture, different way of writing programs, lots of little programs that do one small thing and consume their work from an input log and do things and maybe put an event in an output log. And that's this network of services talking to each other. That's the modern application architecture now, right? And we're building systems that respond right away. They don't just record transactions in a database so somebody can print out a report on a laser printer tomorrow. Okay.
Mm-hmm.
Yeah. Link 182 was on the radio the first time when that was happening. That's just not what we do anymore. So
I mean, they just went on tour again.
I know I know. That's why I said the first
But
time. I understand. They're still, I mean,
the
like
tickets are so expensive.
Journey is still touring. It's a different lead singer. Yeah. Yeah, Robert, we turned the database inside out. That
I like
happened.
that
And
phrase.
so,
That's fun. I like that.
yeah, it's super great. It's now like you're building your own special purpose database. That's what your system is. And Kafka's the event substrate. And the ways we've been doing analytics, which were now, Spark, Snowflake, the data lake, all of these things that are just evolutions of the data warehouse. They're all still ways of taking all of these data sources, dumping them in this central location, and then running reports on it as a batch process. Okay.
Mm-hmm.
The specifics, the difference between an early 90s data warehouse and a contemporary data lake are meaningful and large differences. I'm not saying that they're really the same thing, but they are essentially both batch technologies and this way of centralizing that data. So what we need now that increasingly, instead of transactions being stored in a database, transactions are stored in these events in a log that our services are emitting. We need a way of looking back on that log and seeing what's happening. And it can't be a batch process anymore because all this stuff is happening in real time. So this and LinkedIn built Kafka. And then in 2015, they said, well, it's time for us to build a real-time analytics database because we've got all these events and we're not trying to run reports on them. We're not trying to power a dashboard for a leader to see. We're trying to take what's happening in the system right now and expose that to people in the user interface in real time. So what real time means is I load a web page, I click on a thing, I tap on something on my mobile device. Oh, cute picture. And I am kind of synchronously waiting for it to respond. I, type in a search term, show me hamburgers near me because I'm hungry. I want to know the average delivery time of the 5 burger joints within a mile. I'm not going to wait 15 seconds for report processes to run, right? It needs to be alive and happen right away. So LinkedIn built the original first version of Apache Pinot, we'll talk about next time, to be an analytics database that could ingest streaming events and answer queries in, on average under 100 milliseconds. All of the previous generations of things, and I know I kind of skipped over the data lake. I didn't dwell very long on Hadoop and everything, but it's just a big scalable data warehouse, right? All of those were designed to power dashboards, which are just reports in a web browser, right? And if it takes 15, 30 seconds for a query to run, who cares? I just need it to update every once in a while. That's fine, It used to be overnight. At least it's not overnight anymore. It's okay if that process is pretty slow because I'm just an
Right.
exec looking at a dashboard. But once we're taking data inside the business and exposing it to users in a user interface, now it needs to be fresh,
Hmm.
not seconds old. Latency on queries can't be 10 seconds. It has to be 50, 75 milliseconds. And I don't have 15 execs refreshing a dashboard. I have 100,000 users of my application looking for hamburgers right now. And so you've got this massive amount of concurrency. So the shift here, and this happened because of the second pivot in application architecture. We had mainframe to client server, and now we are experiencing client server to event driven. Those same things are pushing us in the direction of needing these databases that are that can handle many, many more concurrent queries than the previous generation, much lower latency, and much fresher data. There is no batch process, right? You've got your Kafka pipelines. The data's got to come into the database and be available. So there you go. Robert, that Pat Helland quote. I need to get that guy on my podcast. I'm gonna email him right now. All right, after we're done. Anyway,
Did you
that's
also
that's 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 why real time analytics.
um did you see grams of the difference
Yeah,
between a
can I take
data
that?
warehouse and a data
Yeah,
lake?
yeah. Right, right. So if you're a data infrastructure person, data warehouse is like saying monolith, right? You're a little embarrassed by it, and you kind of look down, and you're supposed to fix it, and some shame, right? That refers to the 90s technology of the one relational database that your ETL process is populating. And maybe it's not overnight, right? Maybe it's every hour. We got those cycle times shorter, but it's still this batch process, and it's still that old thing. And then you put a BI tool like Tableau or something on top of that. So data warehouse refers to that. It's under the covers. And you know what? You might get people giving you slightly different answers to this, but this is a reasonable answer, and it's my answer. Under the covers, it's a relational database with that star schema version of your enterprise's data in one place. Data lake is, originally with Hadoop, it was an HDFS cluster, which was a distributed file system technology. These days, it's probably a bunch of stuff in S3 or Azure Blob Store, or blob cloud blob store of your choice. But it's just a bunch of stuff that you dump into that sump of storage, and you don't do a lot of transforming before you put it there. So in the data warehouse, you had this very specialized, carefully thought out process of transforming the transactional schemas in everybody's departmental transactional database into the analytical schema. I said star schema before. You might hear the term snowflake schema, into this fact dimension pattern that, again, it's this specialty of doing that transformation. And you're very carefully making that schema translation, writing code to do that into the data warehouse. In the data lake, you just say, nope, here's the transaction. And there you go into a Parquet file or whatever. You just kind of dump the thing into the lake and worry about transforming the schema later on if you have to. That's the difference between ETL, extract, transform, load, and ELT, extract, load, transform. Um, I think that distinction is a much less revolutionary one than some people have argued, but that's the difference between a warehouse and a data lake. A data lake, you just dump stuff in, you figure it out later.
That totally went over my head, but I'm gonna come back to it, and I know I can refer back to it.
Okay.
And
Okay.
this was very eye-opening and connecting a lot of the dots. I will say next week, because you said that we'll have to refer to some of it with Kafka, and maybe
Mhm.
you can answer this really quick because I've asked a
Yeah.
lot of people this. Is it Kafka or Kafka?
Well, it depends on the accent with which you speak English. And I'm going to say, for your accent, which is the same as mine, you are an American speaking standard spoken American English, Kafka. Um, if you're basically anywhere else in the Anglosphere, well, no, if you're like an Aussie or a Kiwi or a Brit, They tend to say Kafka, and it sounds perfectly natural. But for us here in the States, it's Kafka. I actually
I
made a whole
will.
video when I was at Confluent. It was only internal, but there were these three things because some people said confluent, like people from the Midwest and the Great Lakes area, they said confluent, and the name of the company was Confluent. And so I made this enablement video that said Kafka Confluent. Anyway, it's
Well,
Kafka for us.
I'm gonna probably end up going back and forth because almost the majority of my colleagues are European. So I think
Okay.
I hear
Yeah.
Kafka, or I don't know, now I need to, like, figure out how to write that down.
Yeah.
But that aside,
And
I
I
really
think,
like.
I mean, give them that. They get to say it how they want.
Yeah, yeah, I like how we talked about going from mainframe to client server to event driven to real-time analytics. Next week, something that I think would be really helpful, probably already on the plan, is understanding event driven a bit more. Like, what's an
Okay.
event? Because,
Okay.
like, it makes sense, but not enough. That I think that would be really helpful to build on, because the rest of
Okay.
it really made breaking this down so much easier and understanding it. So that's definitely something to look into next week. And y'all, next Wednesday, same time, same place. So come join us next Wednesday. Make sure you follow so that way. And Ryan, thank you for pinning Tim's Twitter account. I appreciate it. And Learner, thanks for staying awake.
Right.
And Learner is, I believe, in India. So it's
Oh,
like
that's
1:30
late.
in the
Thank you.
morning. Yeah.
Have a good night. Keep learning.
Oh, geez. Um, Thank you, Francesco, for joining today. And yes, everyone, let me see who we should raid to. Oh, Josh is streaming. We're gonna go to Josh because it's always fun to raid to Josh. So y'all are going over there soon and come back next week. And because rating always takes forever, and I like to make funny noises and looks when I'm waiting. There we go. And